Hello class, and welcome to today's algebra lesson, which will cover algebraic expressions. By the end of today's lesson, you will be able to write algebraic expressions and also evaluate those expressions. We're going to start with a little vocab. First, we have variables. A variable is a letter used to represent a number. Couple of conditions we have on that. We are going to use lowercase letters. Uppercase letters have other significance in math, so we're going to use the lowercase letters as our variables. And second, you want to make sure that you are using variables that aren't going to be confused with numbers. So you should not be using the letter O because it looks like a 0. If you're going to be using the letter Z, please be careful that it does not look like a 2. If you are going to use the if you are going to use the variable S, please make sure you can tell the difference between the S and the number 5. And then if you are going to use the letter L, please make sure you are using a cursive L as opposed to a regular lowercase l, which can look like a 1. Next thing we have is an algebraic expression. This is a math sentence that's going to contain at least one number, one variable, and one math operation. Within that algebraic expression, we have things called terms. Those are the different pieces. It can be the number piece, it can be the variable piece, or it can be numbers and variables multiplied together. Terms are separated by adding and subtraction. So for example, if I had 2x to the 4th plus 9 minus 6y, there are 3 terms in that expression. The first and the last term are variable terms. So 2x to the 4th and negative 6y are both variable terms because they have variables as part of them. Positive 9 in the middle is called a constant because it does not have a variable. We're going to start by writing the verbal expressions for algebraic expressions. So we have our expression here, and I want to translate this into words. There are many different ways you could do this. I'm just going to give you a couple examples. So the first one that you could use is to say 5 multiplied, because our first term is being multiplied, by x cubed. Remember that cubed is another word for to the 3rd power, plus 2. When you are writing out the verbal expressions, if a number is 10 or lower, you must write out the actual word. Notice I didn't use the number 2 here. I wrote out the actual word 2. So if a number is 10 or below, you have to write out the actual word. Another example for how we could have translated this sentence would be to say 5 times a number x to the 3rd power increased by 2. Again, these are just a couple examples of the many different ways we could say this. If you're wondering if one of the ones you write out is correct, you can always feel free to ask me in class, and we'll go over a few more of these examples until you get the hang of it. Go ahead and try this one on your own. Again, many different options here. It lists just 3 of those. If you have questions about this specifically, please make sure to ask me when you get to class. One other thing I want to address when we are writing these expressions is if we have to indicate that there is grouping. So notice in this one we have our first term, and then in this second part we have a fraction, which means it's actually grouped together in parentheses. If you are going to be using grouping, there are 4 specific operation words that we touched on in the first video, but I just want to remind you of those. If you need a group for addition, you're going to use the word sum. For subtracting, it's going to be difference. For multiplication, it's going to be product. And for division, it's going to be quotient. So this tells you that they belong in a group together. if you don't want to use one of those words, there is a universal word that you can remember, and that is going to be the quantity. So, for example, if I was going to translate this sentence, this expression, one option I could have would be to say a number a to the fourth power plus the quotient, that's the word I'm going to use to show that it needs to be a fraction or a group with division. So the quotient of 6 times b and 7. So when you are using these grouping words, there's always going to be an and. In this case, since it's division, it tells you what's in the numerator of the fraction and what's in the denominator of the fraction. If you were doing sum, it would tell you what's in front of the plus sign and what's behind the plus sign. Another example for how I could write this one out would be to say a to the fourth power increased by the quantity, again using one of those grouping words to show that I want that to be together. So by the quantity of 6 multiplied by b divided by 7. So again, that quantity part indicating that whatever comes after that is a group together in the expression. Go ahead and try this one on your own. So in this case, when you're doing the group, you can either use the word sum to get the parentheses around that addition, or you can use, again, the quantity, which is that universal word for grouping. Now we're going to go the other direction. They give us the verbal expression, and they want the algebraic expression. So 2 times the quantity of y plus 11. So I'm going to start with 2. Then I'm going to multiply by the quantity. So that tells me I want a group of y plus 11. You can also write this out as 2y plus 11, since you do not need the multiplication sign if you have the parentheses there. Go ahead and try this one on your own. 5 less than a number cubed. Just remember from that first video we went over for our algebra class that less than puts the number after the subtraction sign. So we have n to the third minus 5. Writing an expression when we have these longer word problem scenarios. So in group play stage at the FIFA World Cup, teams are placed into groups of 4 and they play each other. A team is awarded 3 points for a win, 1 point for a tie, and 0 points for a loss. Write an algebraic expression that represents the number of points accumulated by one team in the group play stage of the World Cup. So we have 3 different pieces that we are considering here. First, 3 points for a win, then we have the 1 point for a tie, and the no points for a loss. So we're going to have 3 different terms that we're looking at. I'm going to start with my 3 points for a win, and I'm going to say that that's 3W. I'm picking W because W for wins. Then I've got 1 point for a tie, so I'm going to have 1T, T for tie, and then we have 0 points for a loss, and I'm going to use L to stand for loss. Now I want to figure out the total number of points that is being accumulated. So we have 3W, that's going to tell us how many wins that they had, and I want to add on the amount they get from a tie. Since it's 1T, you could write it as 1T, or you can drop the coefficient there. You can drop that number because it's 1. Then plus 0 times the number of losses. They don't get any points for a loss. Adding on 0 is not going to change our expression. So our final expression is 3w plus t. Go ahead and try this one on your own. So we end up with 100n for the 1-day passes plus 350p for the 4-day passes. Now we're going to talk about evaluating the expression. Evaluate is another word for solve. So we're going to plug in and then follow our PEMDAS steps to solve the problem. So my first step is just going to be to plug in my values. So I'm going to say a, which is 2 to the second power, times 3 times b, which is 6, minus a, which is 2, plus 5, close that parenthesis, and then divide by c, which is 4. Now I'm going to follow my steps of PEMDAS and work inside the parentheses first. I've got multiplication, subtracting, and adding, so I do the multiplication first, and that's going to give me 18 minus 2 plus 5 divided by 4. Because adding and subtracting are in the same group in PEMDAS, we can do that in the same step. So we have 18 minus 2 is 16, plus 5 is 21, and then continue that divide by 4. Moving on to my exponents, 2 to the second power is 4 times 21 divided by 4. Multiplying and dividing are in the same group, so I can do 4 times 21, which is 84, divided by 4, which is going to get me my final answer of 21. Go ahead and try this one on your own. Plugging in, following the steps of PEMDAS, you are going to get a final answer of 3/8. If you turn that into a decimal and got 0.375, that is acceptable as well. Putting it all together now, in 2004, Chad Fell set the record for the largest bubblegum bubble blown. Assume that the bubble was spherical. The surface area of a sphere is represented by 4 times pi multiplied by the radius squared. Write an expression for the scenario, then calculate the surface area if the record-setting bubble had a radius of 25.4 centimeters. The first thing it asks us to do is to write the expression. So it tells us that we want 4 times pi, we can use that pi symbol at this point, multiplied by the radius. That's what we're going to use as our variable. I'm going to choose r. Squared means to the second power. So my first step is to write out that expression. Now it's asking me to solve or evaluate that expression. So I'm going to take 4 times, for our purposes we're going to use just 3.14 for pi, and then plug in that radius value, so 25.4 squared. Now we can go ahead and solve. So I'm going to start by doing my exponents. So 4 times 3.14 times, when I solve that, I get 645.16. Now we've got a couple steps of multiplication to do, and we get our final answer of 8,103.2096. And then because it's a word problem, we need to stick our label on there, so that is centimeters squared. So I want to emphasize for these problems, the first part said write the expression. This is the first part of your answer. Then it said to calculate. So the second part is to actually plug in the number and solve. I want you to go ahead, and the first thing I want you to do is write the expression for this scenario. Now that we have our expression, I want you to go ahead and calculate the value that it asks for. Plug in your games, solve the multiplication and then the addition, and don't forget to put the label. As it is a word problem, you need a label on your final answer. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.